In this video, we're going to continue going through a couple of compounding interest kind of a thing. We just went through this type of problem right here, where this is typically an investment of some kind that is, you have a starting value, you have this rate, it's compounding a couple times per year. These are your different kind of situations for what that N would represent. If it was quarterly, then your N would represent a 4. This means you're breaking the interest rate into 4 equal little parts, and you're earning interest more often. So then your amount of years is typically your exponent, but it could be multiplied by how often it's being compounded. So if it's compounding quarterly, you're going to multiply the number of years times 4, which would represent your total number of years, or a total number of times compounded. So you may see this formula simplified. I'd argue that I don't know if that's exactly simplified, because they generalize this R as just a rate. Well, typically rates are given in yearly rates, and then this formula very nicely breaks it up into these little smaller chunks of how often it's compounding. So this R, they describe it as an interest rate per compounded period. Well, your R really just equals a rate divided by how often you're compounding something. Okay, so that really is just this. And then your N represents how many times you're going to be compounding it, your total number of times compounding. Well, that N is equal to your how often you're doing this per year times your number of years. So it really equals this. So I'd argue that we already have a formula for this. Why create an additional formula? So I'm not going to really focus too much on this, at least on this particular problem, because they don't give this information. They give this information. So I'm really going to do pretty much the exact same thing. So, but there is one little part to this problem that I want to make sure that we answer the problem correctly. It says find the compound interest on an investment of $10,000 that earned 2% annual interest that was compounded semi-annually for 3 years. So let's put all this together. You need an initial amount. Okay, so I'm really kind of focusing on this formula. I need an initial amount, I need a rate, I need how often it's compounded and how many years. So my P is 10,000. My rate is 2% annually. And for 3 years, but it's compounded semi-annually. So our N is 2 times per year for 3 years. All right, so my final amount is going to be $10,000 times 1 plus. Again, I'm just kind of putting pieces into this. So 1 plus my rate, 2 divided by 2. All right, so that's going to naturally break this up into its own rate, which I don't have to worry about. The formula takes care of this. And then I am going to do this for 3 years, but twice every year. So it's 2 times 3 for a total of 6 times compounded. That's what that capital M would represent. All right, but I can let the calculator take care of all of that. So I'm going to throw that into the calculator, see what we get. Put it over here. So we're going to take 10,000, 10,000 times 1 plus 0.02 being divided by 2, and then raised to either I'm going to put a 6 or I'm going to do the 2 times 3. Doesn't matter. And that's going to get me 10,615 and 20 cents. All right, but the question was, that's great. That's how much we accumulated. Went from 10,000 to 10,615. So the question really is how much interest did you get? The interest is that pure 615. So to find the interest, I'm going to do the difference between the two. Interest is going to be what we finished with minus what we started, just the difference between them. And so that one's pretty straightforward. I gained $615.20. Okay, and then one last type of problem is what if you knew where you, what if you were only looking for what you were, you knew where you needed to be in the end, but the question would be, where do you need to start? So it's basically taking this formula and basically solving for a starting value. It's taking this piece and dividing it over to the other side. And that's exactly what's going on here. The language gets adjusted a little bit, where this PV represents your present value. So that would have been the 10,000. But this time, let's say we didn't know that we needed to start at 10,000 and our goal was this value. So our present value is what we don't know. Our future value is what we're shooting for. So we're trying to get a certain value. We know a rate, we know a power to it, and we have everything we need. So it says the store owner needs $20,000. That is known as a future value. And then in 10 years, so our time is 10 to replace some equipment. So we'll put money aside or whatever, because every 10 years, equipment's bad and we need to update it. So find the amount that the firm must invest at present. So we don't know the present value if it receives 5% compounded annually. So that's good. Our rate is 5%. And how often we're compounding it is one time a year. So we can use this formula. Our present value is, we don't know, but it's going to be our future value divided by 1 plus our rate. And we're going to divide that by 1, so it's really not doing anything. And then our time is 10. And since we're compounding it one time a year, we're not going to multiply that by anything like we normally do. Okay. So that's just the value that we're going to plug into the calculator. And that's going to get us our value. How much do we need set aside today? And earning a certain amount of interest for a certain amount of time to get us to 20,000. So we're going to take 20,000 divided by, now you got to be careful with this. This piece needs its own parentheses, just like it looks here. 1 plus 0.05 raised to the 10. And so we would have needed to have started with $12,278.27. And if you would have started with that amount and this investment for 10 years, earning 5% per year annually, you would end up with exactly your 20,000 that you need. Okay, so it's kind of worth working backwards, and you don't have to do the math on it. It's basically taking this and dividing this piece over and solving it for you, just kind of creating a new formula for you. All right, so you just got to know the formula, plug in your information.